Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a very special guest, and that is Alex Cattelan. And she is currently the COO, which stands for Chief Operating Officer of Fermata Energy. You might be familiar with Fermata Energy because we already had David Slutsky, who's the founder of Fermata Energy, towards the end of last year. But after that, he did a very important thing and he hired Alex. And so Alex also has experience with E3 Lithium, which is a lithium mining company, Braun Ability, Brunswick Corporation. They make stuff for boats. And then there's a company called Polaris Inc. At first, I was thinking it had to do with those Polaris connectors, you know, those connectors that you do a supply side connection with oftentimes when you're connecting your PV system or your energy storage system between the meter and the main breaker. But this Polaris is much more fun. They make motorcycles and snow machines and things like that. And she was the VP of engineering there at Polaris. Then she also worked for Chrysler Automobiles. She worked for the very famous Johnson Controls. She was the vice president of advanced battery business. Another company she worked for was AVL. And of course, there is General Motors, the very famous General Motors. And she was the powertrain assistant chief engineer for the Chevy Volt. If you don't remember the Chevy Volt too well, because now they have the Bolt, but that was the car that had an electric vehicle with a gas engine that could charge the battery or connect to the electrical place. Maybe she could tell us a little bit more about that. She was also working for General Motors doing other things, powertrains and alternative fuels. She worked for Westport Innovations Incorporated, also Orotech Consulting, and she was an air quality engineer for something called SENES Consultants back in the 90s in Toronto. And I did a lot of work in Toronto because I was working for the Ontario Solar Academy. I had some great times up there. Canadians are wonderful people. So welcome to the show, Alex. Are you a Canadian?
Thank you very much. I'm happy to be here, and I am very happy to say I'm also Canadian. And I appreciate the fact that you pronounced Toronto the right way. You did not say Toronto. You said Toronto, just like everybody else does. So I know you've spent some time there.
Okay, I didn't even know that. So I better not say it again or I might get it wrong.
No, you did just fine. That's fantastic. Thank you for having me. I'm really excited to be here.
Yeah, and thanks for having such a long group of companies that you worked for that just took me out of breath. So what might I have missed?
I think you actually got all of the organizations that I've worked with, and I appreciate that I've had a long career, mostly in automotive and mobility, and really the opportunity to focus on green energy of some sort, whether it's alternative fuels. I've burnt just about every kind of fuel you can burn: hydrogen, natural gas, propane, you name it, diesel and gasoline too. But then really started working on EVs in 2005 or so, did some 42 volt hybrids at the time. And then one of my favorite programs I ever did was the Chevy Volt, because it was such a unique program for General Motors and the way we worked and who we worked with. I remember every person from that team, including my current CEO at Fermata, Tony Pazowatz, who worked on the team with the Chevy Volt, and that's how I actually knew him.
Can you remind us of what year that was that the Chevy Volt came out?
Yeah, we started the work in 2007. I think it hit the auto show then. And by 2010, it was in production. So it was a fast track, brand new program. We worked with the likes of Bob Lutz, I think most people know in automotive Bob, and some of the highest levels of the organization to create something at General Motors that was truly unique to the industry. First, with the lithium-ion battery in production, as well as very unique to General Motors. And it was one of those opportunities to take a startup-like environment within an organization that really was very process driven. So it was a ton of fun, great technology, and a great opportunity to advance lithium ion batteries and hybrids in the industry.
Yeah, I remember test driving it. I think it was about 2010. It was right when it came out. And what was interesting about that and different is I had a different type of a hybrid. I had a Prius, And that Chevy Volt, I think it was like fully electric powertrain where your motor would be able to make electricity. Is that correct?
Yeah, we called it officially an extended range electric vehicle. So you
Mm.
drove on battery while you had battery power, and then it ran like a conventional hybrid when you had depleted the battery. So that's when the engine would kick in, and a combination of engine and motor propelled the system, but the engine maintained that battery level. So it was really unique. It was the first time an EREV had been put in field. Others have followed it. We were actually in the process of doing the extended range electric vehicle, joining the EPA and others in rulemaking around how fuel economy would be evaluated and it would be regulated. So it was truly a pioneer in the field and a wonderful program to work on.
Yeah, and I don't know if there's ever even been another hybrids that was like that because most hybrids have more of like a mechanical drivetrain, and you were just using your engine solely to make electricity. Does that sound right?
No, the engine was actually engaged to the wheel in hybrid mode.
Oh, I
So
didn't
I
realize that. Okay.
Yeah, so I could get into that whole history, but that history is behind us. But there are plug-in
So
hybrids that have very similar
somebody
powertrain.
lied to me and misled me.
That may have been the case, but there was a lot of confusion around that. I know when the
Mhm.
vehicle got launched, and I think that confusion was clarified at one point.
Maybe it was the guy that took me for the test drive. Must have been his fault.
All right. We won't be laying blame to anybody today. So,
Uh,
but as you mentioned now, really excited coming out of a long history of working on mobility and mobility challenges with respect to CO2 and green energy. Now working with Fermata
great.
and working on bidirectional charging, which leverages bidirectional vehicles or electric vehicles that can both be charged but discharge energy from their battery into the grid or building or other opportunities. So it's new and unique, and I'm learning every day about the charging and charging infrastructure, but really, really promising technology for green energy in field.
Great. And just another thing too is I noticed that you have a couple of engineering degrees, and so you're also an engineer. That's
I
great.
am, yeah.
Mhm.
Ironically, not an electrical engineer. I'm a mechanical and industrial engineer, and I've learned everything I know about electrified systems really through working on them.
So is trigonometry the same for mechanical and electrical engineers?
Trigonometry is trigonometry,
Uh-huh.
and depending
Mhm.
on who you are, you love it or hate it. I loved it. So
Yeah, I remember one time going sailing with two engineers, and one was a mechanical engineer doing electrical engineering, and the other was an electrical engineer doing mechanical engineering. So a lot of things just transfer over and you learn things on the job. Pretty soon you've been doing a lot more and learning a lot more on the job than you did in school after enough years.
that's the fun of it for sure.
Yeah.
Absolutely.
Yeah. So anyway, so you're working for Fermata Energy is kind of famous for going vehicle to grid. And I noticed too, you've got a lot of press releases and things that are going on. Since I also spoke to David Slutsky, you had an announcement too about you have an inverter that is UL 9741 and UL 1741 SA for an AI driven vehicle to grid compliant EV charger. And that's actually a press release from UL.
Yeah, which
Mm.
is an incredible milestone for Fermata. The first UL certified bidirectional charger with our partner Heliox, designed and developed and certified through both Heliox and Fermata. So that's an excellent milestone for Fermata. We actually are leveraging that charger to deploy what is our primary product, which is software models that take advantage of being able to use data science and forecast vehicle availability and driver behavior, battery health, and a number of other factors to decide how to leverage those batteries when they're not being used either for driving or they don't need to be charged in preparation of driving. Our software optimizes when to use those batteries to put energy back to the grid or to manage building loads, and thereby earning consumers money. So I can plug my vehicle into a bidirectional charger, and the money that I save and or earn by managing building loads, if I'm a fleet or a large size building, or by putting energy back into the grid, is enough savings to pay for most of or part of the lease of my vehicle. So it's an incredible technology, and we need those bidirectional chargers, like the ones we develop, to help us be able to do that energy management of the vehicle. So two
Yep.
things need to be true. The vehicle needs to be bidirectional capable, which there are a number of models in field or coming to field today. And you need a bidirectional charger that can plug into that vehicle to either charge or discharge the battery.
That's awesome. And so, by the way, too, we just mentioned UL 9741. And so UL 9741 is the standard for bidirectional EV charging system equipment. And so that is a little bit like 1741, but instead of having a 1 at the beginning for 1741, which is our inverters, which a lot of us are familiar with, inverters are listed to UL 1741. You just take the 1, you swap it out, you put a 9 there, and that's for bidirectional EV charging system equipment. So that's a good one for us to learn. And it's not that difficult because we already have that. So some of the things that you can do is support the grid. And it also says AI driven vehicle to grid compliant. And so how does that work, or what do they mean when they say AI? There's so many different definitions, I guess, of artificial intelligence. And I'm sure that ChatGPT isn't popping up telling people what to do.
Absolutely not. The artificial intelligence really is in the machine learning models. And what those models do is, again, they forecast behavior. So, based on past behavior and data science associated with analyzing that past behavior, we can predict future behavior. So, if you think about it, if I'm a driver, I don't follow a specific schedule every day. But for the most part, most days, my driving schedule, I follow a specific schedule. Now, if you take 100 drivers or 1,000 drivers, and we can look at how they drive, and you aggregate all of that data, you can start to predict how much energy is available for bidirectional charging at a given hour, a given day, or a given season. And that's what some of this machine learning and data science modeling does. So it takes into account factors such as driver behavior. If we're bringing solar into the equation, when we're looking at a system with a building and solar energy and vehicle energy to balance it, you can look at solar loading through weather patterns, right? So you get the idea. As you look at the factors of what you're optimizing and managing, you're leveraging that data science to build forecast models. And those models are self-learning models. Over time, they get more accurate as more data enters into them. And that's really the AI-driven portion of this.
So it sounds a little bit like we are talking about all this AI and figuring out when the electric vehicles are going to need to send to the grid, when they're going to need it to take it from the grid, when they're going to send more, when they're going to send less. It sounds like something that would be working closely what people call a virtual power plant, a VPP. Are you working on that right now, or maybe you would incorporate your technology into a virtual power plant?
Yeah, so that's a great question. Our technology, the essence of our technology, or the main essence of our technology currently, is around cost optimization. So think about 3 areas: demand response, which is the grid side of when energy is low or high and cost is low or high, the ability to predict and forecast future energy prices on a day-to-day basis. And they are forecast on a 24-hour basis. So if you can take advantage of demand response and cost, leveraging the energy in electric vehicles, that's where there's a dollar savings associated with what we do. There's also frequency response, which is another side of grid resiliency, that there is the opportunity to leverage cost benefit by responding to frequency response requests. On the building side, if you have a vehicle to building, you can manage building loads. So we do this mostly in grid uptime. We also work in microgrid or virtual power plant where we can manage energy requests and optimize energy flow between sustainable technologies or renewable technologies like solar and wind and grid and the energy stored on electric vehicles. And we actually work also with stationary storage as part of that play. So we do a ton of optimization across all of the energy producers and energy demand to decide when energy should flow in and out of the vehicle to have the best sustainable response from a CO2 benefit and a cost benefit.
Yeah, and you would probably also want to coordinate with other things such as just loads like air conditioners and things like that. Just for an example, I am sitting here and it's a kind of a rainy day, but for a few minutes here, the sun came from behind the clouds. And so all the PV systems in town are going to turn on. Then when they all turn on, there's this excess of energy, and then the cloud comes along, and then there's like a reduction of energy. And so if we could take a little bit of energy out of the cars when the sun goes behind the cloud, just to let the grid kind of settle into that, that would be very helpful. And we can do a lot of different things. We can do frequency response, as you were referring to. So that would mean injecting extra power into the grid when the frequency goes down. We can do all kinds of things. We do reactive power support. Sometimes we need to make reactive power. And the way that I look at it, just because I am the name of this podcast is Shawn White's Solar and Energy Storage Podcast, I look at all these cars as energy storage, as a resource to help out the grid. And in a way, all these cars that are on the grid, there's way more energy storage in the cars than there is like a power plant. So I'm sitting here in the Bay Area in California, and probably within 5 miles of my house, there's way more energy storage in cars than the largest energy storage system in the world. So if you took 10 cars that had 100 kilowatt hours in it, that's a megawatt hour. 10 times 100 is 1,000. So that's 1,000 kilowatt hours is a megawatt hour. And that's a lot of energy storage there. And we need to like dramatically harness this. And I think one of the things that the problem is there's not enough people out there doing what you're doing and coming up with the technology and putting all kinds of, all the best minds to work to make the technology to make this work. And another thing too is the policy is holding this back, I believe, too. So you have all these different public utility commissions trying to make rules and politics and all that kind of stuff. We need to have our politicians be engineers. Do you want to run for something?
No, thank you. I enjoy running an organization and being able to push from that side. But you're exactly right. If you think about holistically, if you have a fleet of vehicles that are out there with this EV storage, and only a fraction of their time is that energy on board being used either to drive or to be charged to get ready to drive. The rest of the time, the vehicle sits idle, and we're optimizing the best way to leverage that energy without disrupting the opportunity for a driver to drive. So we always have to be ready to schedule the charge when a driver needs their vehicle to be charged so that they can drive it. But in those off moments, rather than just charge it and have it hold that charge until the next time, we're leveraging the battery to be able to bring back to the grid and bring back energy for useful work. And to your point, stationary storage has been something that's been used quite a bit. So not only have natural gas generators been used to support peak loads, right, where they come on and they go off, now stationary storage has been fulfilling that. And stationary storage is just a whole lot of batteries that are doing exactly what you can do with a vehicle battery, right? They're managing energy in and out in response to grid needs. They're great. We work with them, but if you can do the same thing with all the energy that are in batteries and vehicles, which is growing and growing and growing, not only in North America, but globally, you can reduce your reliance on the amount of energy storage you need to put in place. And that's really what we're trying to do. But there's a whole lot of work in optimizing when and how you do that to fulfill the driver's needs and to fulfill the grid storage needs. That's essentially what we're managing, is that optimization.
I would guess that there's somewhere between 10x and 100x of the amount of energy in lithium-ion batteries in cars than there is in stationary energy storage systems. I'm not sure 10x and 100x is 10 times different from each other, but I would even guess too that it might be closer to 100x difference, because there is just so much energy in these cars and they're not really being harnessed. And it's kind of a shame that we do have the technology to do it, and it's just politics kind of that's holding us back. And I don't think it's like the intention of any politician or anything like that, but it's just moving so fast that they need to figure out how to do it.
It is. And I think, to your point, the technology does exist. It is at its early inception, though, quite honestly, with the exception of Nissan's Leaf, which has been bidirectional for a long period of time. The number of bidirectional capable vehicles is pretty small models in field. So, as I was saying, there is some policy catch up that I think needs to be done. The policy is certainly favored stationary storage right now, but I think is just a turn that was needed to help the utility industry. I think stationary plus vehicle storage is what's needed of the future. And we have somebody who is actively working with policymakers. He's their super secret weapon at Fermata. And I think there will be some changes to come. We're certainly being able to affect some of that policy change, but I agree with you. The policy needs to catch up with the capability of both the vehicles and the chargers that are coming.
Yeah, and another thing too that's a big fallacy, I believe, out there is that there are people that say, oh, it'll ruin the warranty of the battery of the car. And so my response to that is like, well, the warranty can just be for cycles or kilowatt hours. And it is a little bit more complicated, because if you cycle it from this percent to that percent, depending on the technology, it's better or worse for the battery. But it's not really bad at all for the battery if you're just using 10% of that battery right in the middle. And I would say that 10% of that battery for an electric vehicle is more than all the stationary, I said that word, sorry, than all the stationary energy storage systems out there. The ones that, those inferior energy storage systems that don't even have wheels.
Yeah, and by the way, stationary storage systems are not our enemy, and we actually work with a lot of stationary providers. If you think about stationary for a second, I will get back to battery, I promise. But if you think about stationary, they're a great starting amount of energy for things like power outages and or demand response, frequency responses we've talked about. But the ability to take mobile energy storage and add them to that energy storage. So think about even opportunities now, and we are thinking about these, where you have natural disasters and you need to add energy to a microgrid to keep things alive until the grid comes back up. You can use your stationary storage for normal size power outages, and then think about having bidirectional chargers in vehicles that can be at the ready to come back. And this works particularly well for fleets, commercial fleets. We work with a lot of bus fleets right now, and I'll get into those projects. So stationary is not the enemy. It's actually somebody that we work well with and consider ourselves as being able to supplement that amount of energy for whatever resilience need you have.
I guess when your car's parked, it's stationary.
Exactly. Going back to the battery side, I've developed vehicles. I spent a lot of time managing batteries and battery health. I actually was at Johnson Controls, spent a lot of time developing batteries for mobility.
I saw that.
And the battery has always been that, I always call it the diva of the powertrain system, because you're managing battery health and battery life. And there are some sensitivities for sure, and battery health and battery life is more sensitive to temperature than it necessarily is to the amount of energy that goes in and out of the battery. It's definitely a factor. But if you look at the amount of energy we're using from that battery over a period of time, it's very low current compared to driving the product. So the batteries are highly rated. We work with the battery health estimation so that we're not going out of bounds to reduce battery life. In fact, when we developed FE20, which is the Fermata charger that we talked about that is UL certified, we also worked with Nissan for Nissan to approve it for preserving battery health, and they have. And in fact, what we do can sometimes extend battery health because one of the safety and health, one of the things you don't want to do, especially in cold weather environments, is have a charged battery. So keeping a battery at a high state of charge at all times is not necessarily the best state a battery wants to be in. So by cycling it, we actually can extend the life as long as we keep the amount of energy and the currents or the power that we use at low levels. So we actually are very confident that our technology does not decline battery health, and we're spending a lot of time with OEMs to make sure that that's the case for models that would be bidirectional.
We interrupt you for a very important announcement. Shaun White's Solar and Energy Storage Podcast has been brought to you by Shaun White's Solar and Energy Storage Podcast. That's right, Shaun White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And so I noticed some other things too, is looks like there's some announcement that you're working with John Deere. That's the tractor people?
Yeah, that's correct. So John Deere has a program where they approve or contract certain technologies, and we happen to be one of them. So that's a project that we have with them to explore bidirectional technology with their applications. And if you think about it, although they're not the highest in volume yet, seasonal applications are wonderful for this technology. If you look at me, for example, I'm an avid EV owner. I own a Chevy Volt, so a pure EV. I own Jeep hybrid, plug-in hybrid, and I own an electric motorcycle. And my motorcycle sits around, I'm in Chicago, so it sits around for half the year not being used. I would love to plug it in a bidirectional charger and make money off of my motorcycle while it's sitting around doing nothing.
And I think too, if you're doing something like that, you could just set like how fully charged or how fully discharged it's going to get and make it so it doesn't damage the battery much at all.
Exactly right.
Take away from the life.
That's exactly right, because I don't need it charged to drive it away at any given time.
Yeah.
If you look at the John Deere program and their applications, they have a lot of seasonal application of EVs, as does boating, as does products that I worked on at Polaris, motorcycles and snowmobiles and off-road vehicles. So those seasonal vehicles are actually a really great use case for bidirectional charging, and hence the opportunity to work with John Deere and explore that capability.
Can you pop a wheelie?
Not on the John Deere product, nor should I, but I can certainly on my electric product. I used to race motorcycles, so I can do wheelies and stoppies, but on an EV, I own a Zero, and it's extremely capable of popping a wheelie, trust me. It's a little bit weird seeing a 58-year-old woman doing that, but on the streets of Chicago, but I think I still can. So it's all good.
Next time I'm there, I'm going to come by and check it out. I want to watch. I have a guy who is doing some work for me, Jose, and he is translating some of my classes into Spanish. And he's also in his spare time, a motorcycle stuntman for Netflix. So he said he's going to teach me how to do some wheelies and jumps and stuff too. I do have a motorcycle license, but not as talented as you. I'm not a racer.
Well, I'm no longer a racer, but I would love to meet Jose and see what he can do as well.
Okay, great.
At Fermata, we do have a number of projects. So, in addition to the John Deere project you mentioned, we are working on school bus applications. There's a lot of
Great.
incentives for school buses to go EV. And again,
And
defined duty
if you
cycles.
and if you think about a school bus too, it's like they take a trip in the morning, they take a trip in the afternoon, and that's just during school days, which are, I don't know, maybe half the days of the year or something like that. And the rest of the time they're just sitting there. It's just wasted potential.
It's a perfect opportunity, exactly the kind of duty cycles that we're looking at, especially if you think during the day there's a lot of peak demand. We're looking at school buses as opportunities also for demand charge management on buildings. So connecting the buses to buildings in the opportunity for power outages, but also just demand charge management. So at that building level, you can manage building loads for payback. We're doing a program with Borg Warner, who has a bidirectional charger for higher power applications, and working with BC Hydro, for example, Lion Buses and Power Tech Labs on a peak demand response pilot in British Columbia, Canada. We've been doing this with Phoenix Motor Cars. We have a couple of applications of our FE20 with Nissan Leafs. One at New Lab, we're leveraging solar power into the mix as well. So solar is charging the vehicle and vehicle is connected to the grid. We've done a multifamily affordable housing project with Blue Hub Energy, which is outside of Boston. And we're demonstrating the ability to save money. So there's all sorts of applications that we are doing now, which are leading to commercial engagements of the future and opportunities to continue to work with both the vehicle suppliers as well as the charger suppliers and bring our technology into that optimization hub.
Yeah, I was driving around Oakland yesterday and I noticed that they had a bus and it was fully electric. And I've seen that in a couple other places too. And I was just wondering for something like that, how many kilowatt hours a bus would use. And I'm sure it's different for different buses, like school buses don't need as much because they just do 1 or 2 hours at a time. But
Yeah, exactly.
but some of these buses, they can go all day and stuff like that. And I don't know, is it like megawatt hour, something like that?
Yeah, it's not quite that. It's definitely hundreds of kilowatt hours. It depends on the bus size and the bus duty cycle, as you mentioned. But batteries are fairly heavy, so a megawatt hour on a bus would be extremely heavy and large. But it's definitely in the hundreds. And if you start to stack buses up, that is where you see, from a fleet perspective, significant amounts of energy. And if you just look at the number of vehicles that are out on the road today, if they were all to be used bidirectional, if they were all bidirectional capable, you could manage significant peak power for the grid. So, to your point, going to John Deere, which are managing a fleet and fleet applications of electric from small to large
Yeah.
products.
What is John Deere doing with electric batteries and all that kind of stuff?
Yeah, I don't want to speak for
Mm,
John Deere, but
mm,
I do know that they publicly demonstrated rather large equipment and small equipment applications for EV, right? So lots of
okay.
opportunity there, agricultural as
Hmm.
well as
Yeah, and I guess a
uh,
lot of the John Deere equipment would be seasonal and things like that. Also, you want equipment to be electric if it could go indoors, so you don't have to smell all the smoke, especially. But that's actually a great market to get people into electric vehicle, the technology and things like that, because we have such a polarized world right now, or at least in our country, where there's people that are just saying, if you're not burning diesel, it ain't cool, or stuff like that. And so getting John Deere in on it, I think is pretty great. And plus, their logo's got green in it. Why not?
exactly. And I would say, having worked in electric vehicles for at least 2 decades, so a large part of my life,
Wow.
the very, very important thing to do to get people into electric vehicles, first of all, make sure the applications make sense to a consumer. And a lot of applications have been targeted at very niche consumers with high income, which is great. because it gets people excited about it, but you have to be able to follow that up with practical applications, right? And so whether it's the automotive industry, agricultural industry, power sports industry, or marine, where electric technology makes the most sense is where you're going to get consumer adoption very quickly. And the other piece you need is to follow it up with education and infrastructure that makes usage of that technology convenient, sometimes even more convenient. And really, that's where we're going with bidirectional charging, because as people drive electric product, and I'm one of them, almost everything that I can convert from gas to electric, I already have, but it has to be convenient. And so I need the infrastructure there and the opportunity to reduce the cost of the technology through savings when I can leverage that technology back into the grid is icing on the cake. So these are some of the things that we need to do. And I agree with you. We need to get over the reticence of electric vehicle adoption. And part of that is finding good things to do with the product to make the product cost less of a hit to the consumer. And bidirectional charging is one of those things.
Yeah, I'm just trying to think of just like different ways that the electric vehicle industry could get into the psyche of the type of person that is not as likely to want to go electric, like people that don't believe that climate change is real and all that kind of stuff. And some of the things that I was thinking of is like, well, there's that Ford F-150, and that looks pretty much can fit that market. Maybe needs some fake tailpipes. I was thinking too, if you know, like rolling coal, have you heard of that? Where like they set their carburetor so it like burns the diesel wrong and it makes a big cloud of smoke and they blow it onto a Prius or something like that. Well, maybe what they could do with these electric vehicles is get those smoke machines that they use for on stages and things like that, and they could make all different colors of smoke and things like that. So they could still do rolling coal and then have an electric vehicle, and they can push a button and there'll be a speaker under there, and the speaker can make some all different types of really loud, disturbing sounds that would make them really like their electric vehicles. Plus the Cybertruck is super, how to say it, high testosterone looking.
Yes. Yeah. I think to your point, definitely you need to appeal to the senses of people. But at the end of the day, there might be some fringe. But if you just make it about a green powertrain, you're really missing a lot, because electric, there are so many benefits to electric, and popping a wheelie is just one of them, right? The low speed torque of an electric product is pretty exhilarating. And Tesla, I think, did a really, really good job of appealing to that community, starting with the Roadster and moving from there. I think there's opportunity to appeal not only to the senses, but to the practicality of consumers with electric product. Just one example from my Polaris days is the electric Ranger. The Ranger is a workhorse, right? It's a off-road vehicle that ranchers and farmers and a lot of people use as a work product. And often handling of gasoline isn't the best thing. Noise, people don't really like the noise of gasoline powered Rangers. So we targeted a product that really meets consumers' needs.
So
Typically, the
is the
consumers
Ranger like it's like a four-wheel small vehicle that's just for off-road? Is that what that is?
That's correct. Kind of a workhorse. It's got typically a little bit of a bed in the back so that you can put things in it. It's a very practical off-road vehicle for usage on farms, ranches, and other things where people need to get around off pavement. But there's typically buildings nearby that you can charge in. It's easier than to bring gas to the product half the time. So if you look at the real use cycles of customers, then and target your product towards those, I think customers make very rational decisions, not just on the cost of ownership over time, but on the practicality of the usage. And the more we can make that cost of ownership reduced, I think the more people will move towards electric. I think that's been the biggest barrier to electric is the cost of the technology.
It's so fun to drive with my electric vehicle. Nobody can beat me at the light except for an electric vehicle. In fact, a lot of times I'm not even trying. I just go like, okay, I'm going 25 miles an hour now. And all the other cars, they're still at the light.
Exactly. I used to love doing this when I worked at FCA. We worked on the Pacifica hybrid, which was also a great product. Plug-in hybrid, again, used electric energy while the battery was full or went into a hybrid mode. But, it's Pacifica. It's like a minivan. They don't call it a minivan, but it's like a minivan. And I used to love being at the light in my Pacifica and people looking at me thinking I was probably a soccer mom, and then just hitting the gas at the light and seeing them in the dust in the back. It was my funnest moments while in Detroit, honestly.
All right.
It's
Uh-huh.
They are amazing products for many reasons: lack of maintenance, the ability to just come home, charge, never have to see a gas station again, the performance of the product. And actually, most of them, credible EVs, are extremely safe, safer than gasoline cars. And people forget that. So they're wonderful products, and we at Fermata are trying to build the adoptability of the product through bidirectional charging and the ability to leverage that product for some cost savings with the grid.
So is there any kind of things that you're working on that you can talk about that's the future that we can be excited about?
Well, I think as we are seeing now again the inflection point of vehicles that are bidirectional capable and chargers that are bidirectional capable, we are continuing to build our software platform for an expanded set of circumstances, including integration of renewables, off-grid and on-grid optimization. And I am here to help scale the organization. It's what I do, is take new technology and scale it into commercial application. And we're on the cusp of seeing that happen in this industry, and I'm super excited to be part of that.
Great, great. So when you're developing software, how does that work? Do you have a team of software developers? I'm close to Silicon Valley here. And in Silicon Valley, they have thousands of people working on a piece of software. And how do you go about that?
Yeah, we have a team of software individuals that are broken up into understanding the front end or customer interface, right? Because there has to
Hmm.
be some interface to the customer to help engage scheduling and understanding the technology and the benefits of the technology. So, what does that look like? We have operations that are mostly based on data science and forecast modeling. So, that is a large part of our team, is figuring out how to build these models, what we call AI driven, data science driven forecasting models, and to continually leverage data and improve those models. There's a back-end side which has to integrate our software back into the charger. So if you consider it like an Apple phone, I have the phone, that's the charger, and then I have an app that needs to interface to that phone. That's our software. So we work with the charger companies to integrate our software onto their platform. And then there's a testing team. So we definitely have a team. We have a cadence of software development. And then we have a team on the commercial side that's helping us understand what new customer requirements and features we want. And we systematically build that software and test that software over time, and then integrate it into the charger, make sure it all works before we release into the field. And that's a constantly integrating and developing schedule based on new features and functions that we want to build in, new systems that we incorporate, and new driving cycles or duty cycles that we think about. So that team is growing. It has grown significantly. It's led by our VP of software and data science, Jack Pfeiffer. He's an amazing individual with a ton of experience in this area. And I think you should probably have him on this
Oh, I'd love it.
podcast someday to ask him more details about how we do that.
Yeah, hook me up. That'd be awesome.
Absolutely.
So if somebody is listening right now and they want to partake in this technology and get involved, and let's say they want to go buy an electric vehicle and get a Fermata bidirectional charger, discharger. We shouldn't just call it a charger anymore because it's also a discharger, or we should say grid supporter or something like that. And
Right.
can somebody do that now? Or how long do we have to wait? I know that the Nissan Leaf has been bidirectional capable for a long time. And I think that was due to the Fukushima disaster
Correct.
that kicked them in gear. But what can people do right now?
Yeah, so there are some vehicles that are out there right now. Unfortunately, there aren't that many chargers to support them. So as we talked about, Fermata has developed the FE20, which is a 20 kilowatt bidirectional charger. You can phone us and purchase it. You need to have a CHAdeMO capable vehicle to connect it to, which
So would
is
that
the
be like a
Nissan
Leaf?
vehicle.
Yeah, yeah.
It's like the Leaf, and you could start today.
I have a Tesla, but it has a
Yep.
CHAdeMO adapter. I don't think that would work, right?
No, correct,
Mm.
because there's two pieces that need to happen. The charger needs to be bidirectional, and two, the vehicle needs to be bidirectional capable, and to a standard. In the case of the FE20, a CHAdeMO standard. So you need the power electronics on the vehicle to allow bidirectional as well. And then it needs to be compatible with the CHAdeMO standard to which our charger is.
So when you say
So,
the power electronics on the vehicle, is that
yep.
something that, say, Tesla or somebody could just tweak with a software update?
No, there's a hardware component and a software component. So the power electronics on the vehicle, hardware wise, need to be capable of managing energy in, energy out of the vehicle, as does the software.
Okay,
So that's why I couldn't take my Bolt today and plug it into a bidirectional charger and get bidirectionality,
sure. Okay.
right?
So I guess what we can do right now is just do sort of an advertisement for the Nissan Leaf and a kick to everybody else to hurry up and get with it,
Uh,
man.
But what I will tell you is we are working with many charging companies today that are making residential or developing residential bidirectional chargers that are CCS compatible as well. And there are many vehicles that are coming into the market or have just come into the market, like Kia's EV9, that are bidirectional capable.
Yeah, and
So
there's
you're seeing these two things come together.
yeah, and there's the F-150, the Ford F-150 too.
Exactly. And the
Mhm.
Ford F-150, I would say, is somewhat bidirectional capable, but it's not truly bidirectional back to the grid. It's a wonderful product that allows you to, at a building level, so bidirectional to the building, to be able to manage load back into your building, but it is not grid capable, is my understanding.
I did
So
read something they were working with Duke on that, and I'm not sure if it happened or.
I think the current technology that they are selling is not capable. So you have to ask questions for sure.
Hmm.
Just like in the beginning of EVs and directional chargers, there were a lot of questions because it was new technology. And part of our role at Fermata is to help debunk some of that. But you definitely want to make sure that you have a bidirectional charger that is compatible with your bidirectional vehicle and that you can get vehicle to grid and vehicle to building services out of it.
Well, I'm near Berkeley, and a lot of people live in old school buses. Maybe I could get a new electric school bus. Yeah, I think it works with that now, right?
Yep, we can
Uh-huh.
definitely get you a Borg Warner charger and a new electric school bus, and you can quote unquote live off the grid by living on the grid
Let's
and
do
making
it.
some money. I
Yeah,
love it.
that'll be a lot of fun. I can't
Awesome.
wait. Yeah, and then maybe I'll take it to Burning Man.
Exactly. Exactly. I'm coming with you if you don't
Okay.
mind.
Yeah, that's a great place for you to show me how to do wheelies on electric motorcycles.
Perfect. It's a future date.
All right, let's do it. All
All
right.
right.
So, is there anything else that you want to talk about or that we should cover?
No, I think we've covered really everything that I wanted to cover, and I appreciate the time with you. It's been a ton of fun, and I look forward to a future conversation where there are many vehicles and many bidirectional chargers that are out in field. I know that's coming soon, and I'm really going to be happy to talk to you about how we are leveraging those to build the future that we see. That honestly, Bill Slutsky started this company 10 years ago and was way ahead of his time. And it's awesome to see the time catching up to his vision. And I can't wait to have a conversation with you a year from now
Let's
when
do
we're
it.
seeing that actually hit field.
Yeah, that's great. We'll do that conversation at Burning Man while we're taking the electric school bus up there and charging the electric motorcycle with it and putting on some goggles, doing some wheelies and some dust devils and things like that.
Perfect. That's perfect.
That'd be great fun. So is there any place that you want to tell people to find you, or websites or anything like that?
Yeah, absolutely. The company name is Fermata Energy, Fermata. You can find us there, and I am Alex Cattelan, alex.cattelan, Cattelan at fermataenergy.com.
Great. Well, thank you so much, Alex Cattelan. I loved having you on here. That was a great conversation. And thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, go to Solar, SEAN. That's solarshawn.com. And you can find out there about classes, all these different places where you get all this great information, because we are in the business of education. That's right, sticking stuff to your brain cells. Get smart.